How's everyone going? You're back with your boy Jono for another quick math lesson. Today we're going to do a linear relationship masterclass. We're going to put all our skills together and really work out any question that could be asked of you in an exam. The reason I'm doing something like this is my students sometimes fail to connect different ideas in the same question, and that's exactly what's going to happen to you in these linear relationship tests. We can ask so many different questions just to test your knowledge, so being able to do kind of everything will really help you out. So what we're doing for this lesson is from one graph, we have to work out every single thing that's on this list. We've got to be able to find out what the gradient is. We've got to find what the x and y intercepts are, find out the equation, the distance between 2 points, the midpoint, future values, perpendicular lines. There's so much information here that it does get kind of overwhelming, especially in an exam condition. But we're going to find out we've got all these skills, and being able to kind of apply them individually will really help. So the best way to look at this lesson is as a giant revision of all the other topics. If you do look at one of these things and go, ooh, I have no idea how that happened, I've got links to every other video in my description below, and you might just want to go see how I did it so you can apply it in this kind of overarching revision lesson. So the first one I've got here is rise over run. What is the gradient? All I've got to do is draw on my triangle between these 2 points and find out how far does it go up and down and how far does it go across. So from this point here at y is equal 5, it goes down 3 squares to y is equal to 2 for the other point. And now from here down 3, I like to put that little negative in, I have to go all the way across from -8 to 4. A reminder, don't just do -8 plus 4 because that'll just give you -4. And that's way too small for this distance. So I've gone across 8 positions and then I go across another 4. So this entire distance is 12. So my rise over run, this m value over here, is -3 divided by 12, which if I put it in its simplest form is equal to -1/4. This kind of tracks, remembering that this is definitely negative because it's going down and it's not that steep, so -1/4 is a really good answer. The next thing I've got to do is find out what the y-intercept is. I can actually just look at the graph to find this out, and that will tell me what the equation is. We can see that it's going through at y is equal to 3 at this position here. So the point is 0,3. That means that my equation, because it's y is equal to mx plus b, is y is equal to -1/4 x plus 3, which all checks out. But we don't want to rely on our graphs. We are just going to check this with our point gradient form. Because we know the gradient is -1/4 and we do have 1 point, we can substitute them into this point gradient formula that's listed there. And just a reminder, you can pick either point, it doesn't actually matter. I'm going to pick -8, 5, just because, and we'll see how this goes. So if I've got y minus 5 is equal to -1/4 x plus 8. I'm going to solve for this. I've got y is equal to -5 is equal to 1/4x, which we know is correct. That was our gradient. And that becomes -2. If I plus the 5 over to the other side, I've got y is equal to -1/4 x plus 3, which is what we had before. This is just a really good way to check your answer algebraically and not rely on the graph. If you've got a bad printout or something, it might be a way you've lost a mark in a test. So just checking with this point gradient form could be really helpful. This next one here is asking, is the point -3 and 3.5 on the line? We'll have a look off the graph first, just to see if we're kind of in the ballpark. -3 is here, up 3.5. That's around this position. So it looks like it's probably not on the line, but we could have gotten a bad graph, a bad line, so we are going to have to check this algebraically. All we have to do for this is substitute in x and y that we've been given into our equation. If it's true, if these two things do equal each other, we know that it is on the line. So this is going to become 3.5 is equal to -1/4 multiplied by -3 plus 3. So what we're asking is, does 3.5 equal 3/4 plus 3? That's equal to 3.75, not 3.5. So does 3.5 equal 3.75? It obviously doesn't, so that means this point is not on the line, which we did kind of guess from the graph, but it's really nice to have confirmation. We also want to be able to find what a perpendicular line is to this line. We've got to remember that the perpendicular line is the negative reciprocal. The gradient of this line has to be going in the opposite direction. We know that it's probably going to look something like this, which is much steeper and positive. So my first line had the gradient of -1/4, and the second line has to flip the fraction and then turn it into a positive, which is just 4. The way that we can check this is, does -1/4 multiplied by 4 equal -1? And it does, so we know that these two lines are perpendicular. Now we're going to find the midpoint between these points. Again, this is one that I love to have a guess at first, and we can see that it's probably going to be somewhere around there. So all we've got to do is find the average between the two numbers. So if I've got -8 and 4, I just plus those together and divide by 2. So I've got -8 plus 4 divided by 2 is -4 divided by 2, which is -2. That tracks to our guess because we said it was going to be around that position. Now we've also got to make sure that we find the y coordinates. We need a point. We can't just have one answer here. So the y value is going to be the average between the two y coordinates, which is 5 and 2. So 5 plus 2 divided by 2 is 3.5. And this is going to be our coordinate. Again, we can see that, yep, there's 3. It's a little bit higher than that. So we know that this answer does make sense. We also might be asked to find the distance between these 2 points. And we're going to use a very similar trick to what we did with the gradient, but this time ignore those negatives. This one goes down 3 and across 12. So all we've got to do is sub this into Pythagoras' theorem because we've made a right angled triangle here. So the distance is equal to the square root of 3 squared plus 12 squared, which is equal to the square root of 153. You might be asked to leave it as a surd, so that would be your final answer. But if you get asked to round it to a couple of decimal places, this is equal to 12.37. And that's all we have to do for this one. We've got 2 more here that don't actually use the graph. We might be asked to change our equation into the general form, and the only skill we need to know for that is how to rearrange an equation, making sure that the value with x is positive and an integer. That's really important. So for this one, I'm going to get everything over onto that y side, leaving 0 on the left-hand side. So this becomes 1/4 x plus y minus 3 is equal to 0. So that's just plussing this over and minusing that over. Now I've got to multiply everything by 4 because I've got a quarter there, which I can't have. So I'm left with x plus 4y minus 12 is equal to 0. And that ticks off all the rules needed for general form. I have a positive coefficient with x, that 1. I've got all integers, so there's no fractions, and I've got a 0 on one of the sides. Finally, I might get asked to extrapolate, right? Put in a value that's way bigger and see if I can find out what the answer is. So for this one, I need to know what is y equal to when x is equal to 100. You could sub this into the first equation, the y equals mx plus b, or you can use the general form. You're going to get the same answer. I'm going to use the general form here just because I hate fractions and stuff like that. So this could be just a little bit easier. So for this, I've got 120 plus 4y minus 12 is equal to 0. I'm going to collect those two numbers and move them onto the other side in one step. So I've got 4y is equal to minus 108. Now I've got to divide 4 from both sides to get y by itself, but y is equal to negative 27, which sounds about right. So I know that we've gone through a lot really quickly here, but it's really common in test conditions to get a really long linear relationship question that's worth like 10 or 15 marks just off one graph. Digging in and finding out all the information from one graph is really, really helpful, and I guarantee that it's going to be a high yield thing for you, meaning that if you just practice this, you will get high marks in an exam on this topic. Thanks so much for watching, guys, and I'll see you later.